Hello everyone. Today's video is a second example of solving trig equations. For our problem, we must find all theta between 0 and 2 pi, satisfying -1 times 1 plus cosine theta times sine squared theta is equal to cosine cubed theta. If you've watched the previous video, you'll recall that our strategy is to move everything to one side so that 0 is on the other side. We then use algebra and known identities to simplify the expression as much as possible. We then try to either factor the expression, look at each factor individually, or if we happen to have a quadratic, we can use a quadratic formula. So let's begin. We start by moving everything to one side. It is typically nice to keep the term with the largest power positive. So I'm going to move the stuff on the left-hand side over to the side with cosine cubed of theta. Now we might notice that this here is under parentheses. We can treat that as an entire object in itself. And there's a negative, so we can simply add this entire object here to both sides. The left side will cancel and become 0, and we will end up with 0 is equal to cosine cubed of theta plus 1 plus cosine theta times sine squared of theta. Now, in this particular case, these parentheses do not mean much because there's nothing to be distributed here. There is technically a 1 right here. However, if we distribute the 1, it does not change what's inside the parentheses. So we can remove the parentheses. I'm also going to move this term here so that it is next to our cosine term. So rewriting this, we have cosine cubed of theta plus cosine of theta times sine squared of theta plus 1 is equal to 0. Now that we have moved everything to one side, what we want to do is look for simplifications using known identities. One known identity is the Pythagorean theorem. The Pythagorean theorem says that cosine squared of theta plus sine squared of theta is equal to 1. If we look very closely, we might notice that we have a sine squared of theta there, and there's also a cosine squared of theta in this cosine cubed term. What we can do here is factor out a cosine of theta from these first two terms. After doing that, we get cosine of theta times cosine squared of theta plus sine squared of theta. This 1 over here did not have a cosine to factor out, so we leave that as it is. Now what do we notice after doing this? Well, we have the Pythagorean theorem right here. Cosine squared of theta plus sine squared of theta is always 1. So we can actually get rid of that. That is 1, so we have 1 times cosine theta, which is just cosine theta, plus the 1 that we had off to the side there. This is equal to 0. This is a very nice simplified expression, and it consists of just one factor. That factor is cosine theta plus 1, and that must be equal to 0. We can then solve this in the usual way by moving the 1 to the other side, and we get cosine of theta is -1. Cosine of theta equals -1 is the x-coordinate. X equals -1 is over here. So what we now need to do is determine what angle puts us at this location on the unit circle. We recall a pi radian rotation is a half circle. So that means that the angle we need is pi radians. What this means is that cosine theta equals -1 implies that theta is equal to pi radians. Now there is no other location on the unit circle where the x-coordinate is equal to -1. And if we look at the original problem, we require that theta be between 0 and 2 pi, so we may not rotate around the unit circle more than once. So what this means is that the only solution to our original trig equation, -1 times 1 plus cosine theta times sine squared of theta equals cosine cubed of theta, the only solution to that trig equation is theta equals pi.